Okay, let's straight away start question one. Diagram one shows the standard representation of the atom Z. Okay, so this one is SPM 2021 paper one. So which of the following diagrams shows the correct atomic structure of the atom? Okay, so you see that this is a standard representation. This is, by the way, is Form 4 Chapter 2. Okay, this question is Form 4 Chapter 2. Where's my... So in this case, you see, you got 4 different answers here. Okay, and you have 2 different types of diagram. But let me ask you first, what does 11 stand for?
Nuclear number.
Okay. Wait, why so laggy one? Okay, so this is a nuclear number, yes? The
Yes.
bottom number stand for?
The bottom number is the proton number.
Okay. So based on this proton number, what is the electron arrangement of the atom? Based on this, what is the...
2
yes?
2.3.
2.3? Okay, it means you have to find 2.3, is it? But they ask for atomic structure. Okay. They ask for atomic structure. Why so laggy? Okay, atomic structure. Okay, so you see, which one is electron arrangement? Okay, A and B is electron arrangement. If they put symbol means electron arrangement. So of course you cannot choose A and B, right? Unless they ask electron arrangement, which they here ask for. Atomic structure means in the nucleus you write the number of protons and number of neutrons. So you find which one is 2.3. C is 2.3.
It's 2.3.
So donkey is 2.5. So the correct answer is C. First one can?
Can.
Okay, question 2. Which of the following atomic models was represented by Rutherford? Okay, so I teach you a shortcut. Okay, so you can remember as date. Okay, date Rick Boschan. That Rick Boschan. So it means DA stand for Dalton. Dalton came up with atom. T stand for Thomson. Thomson came up for electron. Okay. RIP, RIP. R stand for Rutherford. Rutherford came up, discover proton. So you find out, right? The one that got proton is B, C, and D, right? But you see, until Rutherford, we only have atom, electron, proton. So electron, proton. Okay, so the answer should be B. The answer should be So then the Boschan, Bohr, BO is Bohr. Bohr came up shells. Like this, shells. Then the Chan, which Chadwick. Chadwick came up with neutron finally. So we only want the Rutherford discovery. Second, okay?
Okay, sir.
Okay, third. This one, by the way, this one is also Form 4, Chapter 2. Question 2. Where are you? I know I saw the game, but so sorry. Okay, third one. Okay. This one, very simple one. If you see, you see underground water pipe leakage. Okay. Detector. This is sodium 24. Where you see, this is sodium 24. You see underground water pipe leakage detector. This is donkey 24. This is the fertilizer absorption. Okay, to study the absorption. by plants. For phosphorus 32. Carbon 14 is they want to
Fossil fuel lah.
yeah, fossil fuel the age predict the age of fossil fuels. Yes. So cobalt 60 is to kill cancer cell.
The thyroid?
Thyroid is one ILD 131.
Oh,
Yeah, ILD 131. Okay, question 4. Which of the following came up? Which of the following is the correct answer? So let's look at this. Okay, first one, zinc chloride has 6.02 times 10 to the power of 24 formula units. So they ask which one is equals to 1 more. 1 more. So, of course, you have to use a street formula, right? So I write it for you. The number of, four formula total. So number of mole equals to mass over molar mass. By the way, question 3 is also form 4 chapter 2. Question 4 is form 4 chapter 3. So mass over molar mass, volume over molar volume, number of particle over Avogadro constant. Okay, so the first one, zinc chloride now has 6.02 times 10 to the power of 24 formula units. Okay, so this is wrong. Okay, this is wrong, because if you're talking about the whole zinc chloride, the whole thing is only 1 unit. Okay, which is 1 unit is 6.02 times 10 to the power of 23. Because if you multiply 1 more, because the thermite number of mole is 1, multiply 1, so we also get 6.02 times 10 to the power of 23 units. Okay, and if they ask how many ions how many ions? How many ions then? You just multiply 3. Because zinc chloride got 3 units. You might ask, how do you get 3 units? Okay, so in this case, if they ask for 3 units, you see, Zn2 plus got 2. Cl minus got 1. Yeah, so that's why you just use this value, multiply 3, then you get like 1.806 times 10 to the power of 24. But
Teacher,
which is also not matching. Sorry?
why 3, teacher?
If they ask for how many how many ions, they got 3 ions. Why 3? Because you see that, let me think, Zn2 plus actually got 1 only, sorry, then Cl minus got 2. You see that, so that you need, you see, here got 2 positive. Why I keep lagging? 2 positive, then you got 2 negative here. They only can cancel out the 2 positive. Yeah, so that's why you need 2 Cl minus to cancel out the Zn2 plus. So total got 3 ions. So doesn't matter. First one is wrong. Okay. Second one, sodium chloride has mass 58.5 gram. So you can use this formula. Number of mole equals to mass over molar mass. So it means if I want to get mass, I use number of mole multiply mole. I use molar mass multiply mole. So mole is 1, right? And molar mass for sodium chloride is NaCl. NaCl, just use 23 plus 35.5. Then I will get 58.5 gram. So the second one is correct. Third, the volume of carbon dioxide gas at room condition is 2,400 cm cube. So again, if you want to get volume, what do? You
Over
use
molar
number of mole multiply molar volume
volume to
to
get
get volume. So what you do is, again, is 1 multiply
1 multiplied
Molar volume is 24, right? But molar volume is dm cube. So after that, you will get 24 dm cube, right? But if you want to change to cm cube, multiply 1000. So you get 24000 cm cube, which is wrong because here got one less zero. Okay, so the third one is wrong. Okay. Again, lucky. I don't know why they're a bit lucky, but yeah. And then fourth, iron has 6.02 times 10 to the power 33 atoms. Correct. Iron is single. Okay, it means if you use 1 multiply 6.02 times 10 to the power 33 atom, then I will get 6.02 times 10 to the power 33 atom. So fourth is correct. The answer is donkey. Okay.
Can teacher.
Fifth, diagram 2 shows the apparatus setup to determine the Ambrager formula of metal oxide. This is Form 4, Chapter 3. Okay. So, which of the following metals uses the same method to determine the Ambrager formula? So, this is obviously, they already told you, this is the experiment where magnesium burned with oxygen gas. Okay. They will open the lid so that oxygen can enter and react with magnesium. Okay. This is to determine the Ambrager formula for magnesium oxide. Right. So normally in Form 1 Chapter 3, you got two experiments for this part. One is using Mg react with oxygen. One is using CuO react with hydrogen gas. But this one using crucible means magnesium burn with oxygen gas to get MgO. Okay, but they ask you which metal also can replace magnesium. Okay, you got two. Either you can use aluminum or sorry, I mean, don't know what's happening. So either you can use aluminum react with oxygen like this. Okay. Wait. Sorry, or you can use also zinc react with oxygen.
Teacher,
Either you
why
use
copper cannot? Because zinc and copper are both less reactive than magnesium, right? So why copper cannot also?
copper. No, actually, because copper is not reactive towards oxygen.
Oh,
Yeah,
okay.
copper is not reactive towards oxygen. So in this case, based on the reactivity, right? Remember the reactivity of metal? Please stop calling me a careless zebra, right? It's alright. So for the first three, it's not reactive. At random start up. Then, okay. So yeah. Sorry. I don't know why it's so laggy today, but oh. So the first question is C, second question B, third question donkey, fourth question donkey, fifth question I'm talking about. So in this case, okay, eh, KNSCA, these three is too reactive. That's why normally don't do experiment too reactive. Okay, normally for magnesium, aluminum, and zinc, this one react with oxygen because the bottom one not so reactive towards oxygen. Reaction too slow, no reaction. So it's like for the other one, right? For the other like iron, like tin, normally we use the oxide to react with hydrogen gas. Okay, this one we use the oxide like FeO, SNO, PbO, CuO, Ag2O. This one you react with hydrogen gas. Oh, okay. So, and then the answer is C. Magnesium or aluminum or zinc can use the same method for the reaction with oxygen. Okay, question 6. Okay. Table 1 shows the prime number of two elements in group 18 of the periodic table of elements. Which of the following is a correct statement about X and Y? This is actually Form 4, Chapter 4. Okay. So, X, prime number 2. What is the electron arrangement? 2. Y, 18. What is the electron arrangement? 288. Okay. So maybe you all can recognize already. Okay, actually, X is helium, Y is argon. So they ask you which one's smaller and all this. Okay, so down the group, normally size increases. So it means argon has the bigger size compared to helium. So if they say X and Y is smaller, that is wrong. Okay, Y is supposed to be bigger. Pen not working. Okay, supposed to be bigger. B, melting point of X is higher. No, melting point down the group, right? Down the group increase. So if melting point of Y is higher, they should be correct. That should be B. Force attraction between atom X. Atom X is weaker than atom Y. Okay, larger size means stronger attraction force, not the other way around. Number of shells filled with electron for atom X is more than Y. No. Okay. X only got one shell, Y got three shells. So wrong. It's supposed to be less than.
Teacher, teacher,
Yes.
teacher, but why is the force of attraction between atom X like why is it weaker? Because it had I thought like smaller size means then the attraction force stronger. So
No, for group 18 it's stronger actually. Will be
both
stronger.
both are
That's why
stronger.
it's harder to melt. That's why melting point higher, right? Because the attraction force is a bit strong. The van der Waals force is a bit strong. They need to absorb more heat energy for the big size particle. So then only they only can melt or boil.
Oh,
Yeah.
okay.
So it's the other way now. Bigger size, in this case, bigger size harder to melt. Yeah, because has a stronger force. Okay. 7. This is Form 4, Chapter 4 also. Okay. So diagram 3 shows a formula of two ions. This is one of the special characteristics of transition element. This is 4.7. Okay. So this is the special characteristic about the transition elements can form complex ions. Can form complex ions. So the answer should be the only answer should be A. Yeah, A, like you see iron, copper, nickel, like this. Okay, iron, copper, nickel, normally like this three. Chromium, manganese, like iron, copper, manganese, nickel, chromium. All these have color. All these can form complex ion. Even though zinc is in the transition elements, but it's not qualified as transition elements. Okay, calcium is group 2, aluminum is group 13. So it's not transition element. Question 8. Diagram 4 shows an illustration okay, of conversation between atom P and atom Q. So this one, wait, again, so like, oh no. Wait, this one is Form 4, Chapter 5. Okay, so they tell B, I'm talking about, oh, I'm group 14, means it has 4 valence electron, right? Group 17 means this guy has 7, Q has 7 valence electron. Okay, both considered as non-metal. Both considered as non-metal. Normally metal is 1, 2, 3 valence electron. If you see 4, 5, 6, 7 valence electrons, means non-metal. So it means in this case, you can already think lah, this is non-metal, right? Non-metal. So the type of chemical bond form very easy. This is covalent bond. Like if you want to know information, 2.4, 287. Okay. So in this case, P will only share to Q1 electron, Q will only share to P1 electron. But P has not achieved because P needs total four atom Q to share to P, each one share to P1 electron. Share one, share one. That's why the formula total is PQ4. PQ4. Normally lah, okay, normally. Yeah. Example lah. Normally example is the tetrachloromethane. Okay, question 9. Diagram 5 shows the conversation between two students. This is also Form 4, Chapter 5. Okay, magnesium oxide cannot conduct electricity in solid state, but can conduct electricity in molten state. Okay, this is the physical property of ionic compound. Okay, so ionic compound made by what? Of course, made by ions, made by one magnesium ion and one oxide ion. So total made by 2 ions, right? And what about the other guy say? The other guy say magnesium alone can conduct electricity in solid and molten state. This is the metallic bond. This is the metallic bond, 5.6. Okay, so promotion 5.6. So where I told you, right? Because magnesium itself will donate the valence electrons to form positively charged ion and also the delocalized electron. Delocalized electron will eventually form C of electron. So between the positive ions and the C electron, it will form electrostatic attraction force. That's why metallic bond form. So then what you can say, magnesium and magnesium oxide, okay, made by ion is correct. Made up by ions. Okay, but in this case, because you know, because actually A and B, A is correct, but A for this one is wrong because you cannot just say made up of atoms. Okay, because eventually this thing will donate electron, you have to say the C of electrons and also the positive metal ion. So in this case, the best answer should be, okay, C metallic bond strong electrostatic force, which is possible, but you don't say held by strong metallic bond. You say held by strong, also you can say electrostatic attraction force. Okay, so it's not only atoms, it's like the metal ion and the C of electron. So donkey is also wrong because it's not weak. Both are strong lattice structure. So the best answer is B. Okay, best answer is B. You see the word. Wait, normally you see either you see delocalized electron or C of electron. For the magnesium metal, for this one is free moving ions like Mg2 plus and O2 minus. Yeah. Yeah, why it can conduct electricity? Yes. They are talking about the part for electricity part. Yeah. So this one sometimes students you get wrong, okay, because it's a little bit confusing sometimes. Like B and C, right? People normally just circle one of them. I think so. Okay, question 10. Okay, so this one, if you see this diagram, you see this one. Diagram 6, so already told you that formation of bond. Eh, what? Okay, why is it so laggy? I don't know why. Wait today. Okay, so you see, what does this call? What does these two electrons call? This one is also form 4, chapter 5. Lone pair of electrons, yes. Lone pair of electrons. I told you, right? Nitrogen 2 rich already. Okay, so the electron entropy is 2.5, right? After share 3 electron with H, after forming 3 covalent bonds, this one is covalent bond, okay? Then it still has 2 electron extra. We call it lone pair of electrons, or you can say the free lone pair of electron. So, but the boron is poor, right? Boron is 2.3. Okay? 2.3. But in this case, boron is a semi-metal. It's not a metal. So that's why boron normally we form covalent bond. With these 3 fluorine, after sharing up 3, no more extra outside. Poor guy. Okay? So that's why between them before, they diff bond. They diff bond. Okay? It means nitrogen being the generous man, straight away contribute 2 electrons share to boron. Straight away share to boron. Okay, so you can say which one is correct statement? Transfer electrons between metal atom and non-metal atoms. No, this is ionic bond. B, sharing of electrons between non-metal atoms that come from one atom only. Correct. This is the keyword. The contribution comes from one atom only. C, hydrogen atoms bonded with atom with high electron negativity in another molecule. This is hydrogen bond. Okay, B is native one. Donkey is sea of electron and positively charged metal ions to form electrostatic force. This is metallic bond. So the correct answer is B. Okay. 11. Diagram 7 shows the ionization of a substance in water. This is Form 4, Chapter 6. Which of the following statements is correct about the substance? So, as you can see, now, you see, this is atom N, then this is atom H. You see, it means what is this compound? Who can tell me? If the white circle is H, this circle is N. The dotted circle. Yes, this is NH3. This is ammonia, right? So you have to recognize yourself. Okay. So and apply, yes. After put inside water. After put inside water. Okay. So you got one oxygen here and also one hydrogen here. I mean this is water lah. Okay, this is water lah, basically. So you see, now there is only one NH4 plus. And actually, this is hydroxide ion. Okay, and actually this is hydroxide ion, right? So, means what? A lot of them is ammonia, ammonia, ammonia. No charge, but there's one charge here. It means they're talking about this is, yes, ionized partially, yes, okay. Ammonia normally is a weak alkali. It's a weak alkali that ionized partially in water, not complete. This is partial. Only 1% turn to ion. Okay. pH value more than 7. Obviously, this is alkali, right? Of course, pH value more than 7. Low concentration of to produce low concentration of hydroxide ion. C is correct. Donkey high number of more of hydrogen ion. No, no hydrogen ion, not high. Okay, easy. I mean, you have to recognize that this is ammonia, right? Then it'll be easy for you. Yeah. Any question? Sometimes they use diagram to confuse you, so you have to recognize yourself. Question 12. Diagram 8 shows. Why so laggy, man? Oh no. Diagram 8 shows the observation of an experiment when substance X is added in two solutions. What is this? Wait. Okay, so this is Form 4, Chapter 4. Okay, so they want to test. Okay, it's the pH one. Okay, one is they test with nitric acid. The other one test with sodium hydroxide. This is the pH experiment. Okay, so to see substance S can dissolve in where? Dissolve in acid or dissolve in alkaline? Because nitric acid is an acid, sodium hydroxide is an alkali. So, see, substance what? Substance X pour into acid become colorless solutions. Means X can dissolve in acid. But can it dissolve in alkali? No. Cannot dissolve in alkali. What is substance X? So actually, in pH3, you got this, if in case you don't know, wrong. Okay. So in this case, okay, wrong answer. So you got sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. So you got a the oxide is sodium oxide. Okay, so yes, you are correct, miss. So in this case, you see how this is oxide, in case you don't know, Okay, so of course argon is not reactive, that's why I don't have any metal oxide. So these two, we call it basic oxide. These two is basic oxide. These four are acidic oxide. Aluminum one is called amphoteric oxide. Okay, be careful. Basic oxide means itself, we call it alkaline, has alkaline property. Only can dissolve in acid. Acid oxide means only can dissolve in alkaline. Amphoteric means dissolve in both acid and alkaline. So, but you see the second experiment, X cannot dissolve in alkaline, only dissolve in acid. So it's either be Na2O or MgO. So the answer is A. Yes. B is amphoteric. C and donkey is they are acidic oxide. But here is basic oxide. Okay. Means very simple. Basic can react with acid. Acidic can react with alkali.
Teacher, what is amphoteric?
Amphoteric means like aluminum oxide means can react with acid, can react with alkali, can dissolve in both. Yeah.
Okay.
So any question? Yeah, especially about aluminum oxide. They always frequently come up. Okay. So 13, Form 4, Chapter 6. Okay. Diagram 9 shows an experiment to produce salt R. So what salt solution can be used to replace lead-2 nitrate solution to produce salt that has the same solubility as salt R? Okay, so you see these two, these two is lead-2 nitrate and zinc sulfate. So you try, if lead-2 nitrate react with zinc sulfate, what do you get? First, Pb2 plus will attract sulfate ion to form PbSO4, lead-2 sulfate. Then the Zn2 plus will attract NO3 negative to form zinc nitrate. So the important point is not the zinc nitrate. The important point is the lead-2 sulfate, because lead-2 sulfate is an insoluble salt. Okay, so it means this is insoluble salt. The R they are pointing the R, right? So which one is? They're asking what salt solution can be used to replace lead-2 nitrate. Okay, so obviously, which sulfate is insoluble? Which sulfate salt? Okay, most sulfate salt they are soluble. There are three that are insoluble. The persatan basa Cina. PbSO4, CaSO4, BaSO4, insoluble. Yeah. So it means I can use either barium nitrate to prepare. I can use calcium nitrate to prepare. I will get an insoluble salt. Am I right? Yeah, so it means I use calcium nitrate is correct to get insoluble salt. This one is a bit tricky, okay? It's a bit tricky. But you have to know PbS4 is insoluble. Yes, your calcium can bring you insoluble salt. Cannot be copper. Copper, right? You will get copper 2 sulfate. Copper 2 sulfate is a blue solution which is soluble. FeS4 soluble. MgS4 soluble. So cannot. We only can get calcium. Yeah. This one, if you don't know basic, then it'll be troublesome. Okay. Yeah. And then question 14. This is Form 4, Chapter 7.
If you can scroll up a bit, I want to see the
Okay,
working.
okay.
Okay.
Circle B, I type C.
Okay, thank you,
Okay,
sir.
okay, no problem. Okay. Okay, this one is Form 4, Chapter 7. Okay, so they already told you lah. Okay, I forgot the label. Okay, the first one is set P. Then this one is set Q. At the right. So here they told you already, inside got calcium carbonate, solid sodium calcium carbonate, which is CaCO3, and react with nitric acid, HNO3. So what do we get? calcium will attract nitrate to form calcium nitrate. The other two normally H and O, H2O, C and O, carbon dioxide. After balance, okay? So they ask what? Wait, what cannot lag you? Again. Okay, so which of the following statements explain the observations? Reactive particles in set P move faster. Okay, so you see, which one? Okay, it means you have to see what is the difference between these two diagrams? Yes, okay. So of course it's size. Yes, okay. Even though it's quite small, okay. Hope you can see. So the matter is size. Which one size bigger? P. P size big. Q small size. Remember, big size means total surface area exposed becomes smaller. Rate of reaction normally is also lower. Okay, so if the rate of reaction, if the Q total surface area larger, normally rate of reaction higher because the frequency of collision will be higher. So P, okay, P is reactive particle inside P move faster. No, wrong. Okay. So B, more particles of calcium carbonate are present in set Q. More particles, no. Okay. It's not more, it's the same. Total surface area of calcium carbonate in set Q is larger. Yes, so C is correct answer. More barrier particles achieve low activation energy. No. Okay. We are not talking about catalysts. Okay. 15. Diagram 11 shows two graphs obtained from the reaction between sulfuric acid and magnesium ribbon. This is also form 4,7. What are M and N? So you see, normally M increases, N decreases. So you see, the reaction is between sulfuric acid and magnesium ribbon. So, which is Mg plus H2SO4, you will get MgSO4 and hydrogen gas. So, they got many things to measure. Okay. So normally what do you do? Normally the most common thing is we measure the increase in the volume of hydrogen gas because normally product will increase, right? But you also can measure there are alternatives. Okay, alternatives. You can measure the quantity of the reactant, whether they are increased or decreased. Okay, so for magnesium, right? Magnesium solid, right? You can measure the mass of magnesium. Normally, of course, it will decrease. Normally, will decrease. Or you also can measure the concentration. Normally, this one is very rare. Concentration of sulfuric acid, which will also decrease. Okay, so normally reactant will get decreased, right? So of course, reactant getting lower, product getting more after reaction. Okay, because at the end of the day, this is what matters, right? What form, right? So, you see the graph, right? The graph increases for M and decreases. Okay. Decreases. So increases means you only find this one, find the volume of hydrogen gas, which is donkey, right? For N, it can be either mass of magnesium ribbon or concentration sulfuric acid. So the best answer is donkey. If you don't understand, you ask me. Okay. Question 16. This is Form 4 Chapter 8. Pewter is a mixture of R, copper, and antimony. So this one is very basic. Okay. So R is tin. Who is tin? Okay. So in this case, pewter made by 95% of tin, 1.5% of copper, and 3.5% of antimony. So the answer should be B lah, tin.
Sure.
Yeah.
Yeah, I don't really understand number 15.
15.
Yeah,
Which one understand?
the graph.
This one.
Yeah.
Normally, you see the rate of reaction graph is in like this, like M, right? Like how much time taken to collect the volume of hydrogen gas, correct? Normally you see this one. I'm sure you have seen this, right? You see the graph increases, right?
Yes, teacher.
Yeah, so normally M should be volume of hydrogen gas. Normally, at the beginning, of course, before you get this, do you have hydrogen gas? No, right? So then only after you put these two together, then only you get hydrogen gas. That's why hydrogen gas, of course, from 0 increases to I don't know how many, maybe 60, maybe 100 cm cube. So of course, hydrogen gas will increase, which only donkey can match.
And
But the reactor normally decrease. Let's say you cook something, you add I don't know, again, salt or whatever, okay, but normally the salt will dissolve, isn't it? At the beginning, you have the salt when you're cooking, but when you add into the dish, the salt will just dissolve, right? Will just disappear. Same thing, okay? Magnesium add into acid, magnesium disappear. So that's why normally these two, right, normally decreases, getting lesser and lesser. Doesn't matter with mass of magnesium or concentration of H2S4. Both will increase or both will decrease because they will react to each other to form a new product. Okay.
thank you.
17. This is also from 4 chapter 8. Okay, diagram 2 shows the diameters of the dents, which are diameter of the dents. So you have to read the question first. Okay. To investigate the hardness of 3 different substances, PQR. So what are PQR? The correct arrangement of the substance in ascending order. So basically, this one is very easy. I mean, not if you know what they're asking is very easy. Okay, so the choices are between steel, copper, brass. Okay, so now you know copper between this side. Confirm copper is the weakest. Okay, because the other two, they are alloy. Normally alloys are harder. Okay, so of course this one is a bit not hard lah. Okay, pure metal is a bit weaker. So it's why this one normally we get larger diameter of that. Right. There's an experiment. Okay, actually, I don't know if you still remember. The experiment is about the steel ball. You let the steel ball drop, and to test the quality of the alloy or metal. there's an experiment. You let the steel ball drop to the any metal block or alloy block. Okay, if the diameter getting very big, okay, like this, it means after that. Okay, this is beginning. Wait, this is the beginning. If you see after you get like this, after the ball is being dropped, it means this one is very big. Not a very strong, not a very hard metal. So normally copper is the weakest here. You get the largest diameter. So normally R is copper lah. So then you compare brass with steel. Brass is copper and wait, I forgot it. Brass is copper with okay, they got bronze and brass, right? Bronze is tin, right? Brass is copper and zinc. Steel is iron and carbon. So of course, which one is harder? Copper or iron? Steel, okay, besi. Of course, besi is harder, right? Iron is harder, iron is stronger. So that's why normally iron we have the smallest length. That's why Q is iron. Of course, your besi can tahan more. Okay, it means iron, the diameter of that is like this. Right? So for P, right, brass is like this. Alloy normally stronger one. Okay, normally alloy, these two alloys stronger. So for P is brass, the copper plus zinc. So the best answer is diameter ascending hardness in ascending order. From not the hardest to the hardest. Not the hardest is R followed by P followed by Q. R, P, Q. R is copper, so the answer is B. It's okay.
Answer.
Yeah, can I? Okay. Question 18. Can one. Wow, confident. Okay. Diagram 30 shows a chemical cell, which means vortex cell, same thing. This is Form 5, Chapter 1. Which of the following is the correct process that occurs at X and Y? So they told you what sign is this? Vortex cell. Vortex cell. Anode is what? Negative or positive? Negative. Cathode is positive. So it means X is anode negative, Y is cathode positive. So which also means anode undergo oxidation, donate electron. The metal will become thinner, right? Cathode undergo reduction, one package, receive electron, the electrode become thicker. So let's see which one is correct. Again, so laggy. Oh no. Okay, so loss of oxygen. Okay, so it means you have to remember this. Okay, so oxidation, you can remember this O1. Okay, O1 stand for, wait, yeah, so it means you have to remember this. So oxidation means gain oxygen, lose hydrogen, increase in the oxidation number, lose electron, reduction, the value of everything. Lose oxygen, gain hydrogen, decrease in oxidation number, gain electron. So let's see. Okay. Oh no. Okay. So loss of oxygen wrong. A wrong. B is correct. C wrong. D wrong. Yeah, the answer is B.
Teacher,
Yeah.
actually, I don't really understand question 17.
Question which one?
17.
Sorry.
17.
17. In summary, 17. Copper is not the hardest. Okay. It's the softest. Steel is the hardest. Softest means diameter of them is bigger. I'll show you that. Okay. So imagine. So laggy. Oh my god. Wait, sorry. Means if it is copper, the diameter of them is like this. If it is brass, the diameter of them is like this. If it is steel, diameter of them is like this. So it's why you see the circle for diameter for steel is smallest. Now do you answer?
Answer.
You just imagine you just let the ball, the very hard ball, drop towards your steel, towards your brass, towards your copper. Copper confirm the whole thing almost gone already. Almost like this. Okay. So answer? Yeah.
Answer.
Yeah. Copper, steel, smaller diameter. Okay, 18 18 I told you already is the answer is B Okay, 19. Okay. Metal M reacts with hydrochloric acid to produce salt and hydrogen gas. What is the reaction that occurs in metal M? Okay, this is Form 5, Chapter 1 also. So imagine M react with hydrogen gas. I mean, hydrochloric acid, sorry, to produce your salt. Okay, let's say your salt is MCl2 and hydrogen gas. So what is the reaction that occurs on metal M? Yeah, this one is very easy lah, right? So metal M can be like zinc, can be like, magnesium, can be like aluminum, can be like iron. Let's say it's zinc lah, right? So let's say the oxidation rate is 0, right? It means let's say M is 2 plus. Okay, normally it's 2 plus. Like zinc, iron, a lot of these are 2 plus. So normally M will have the increase in the oxidation number because increases from 0 to positive 2. 0 to positive 2. Yeah. And then meanwhile hydrogen different. Hydrochloric acid, the H is H plus. H is H plus, but the H decreases the oxidation bar decreases from positive 1 to 0. See, I told you just now, right? If the oxidation number increase from 0 to positive 2, from M2 plus, this is oxidation. Then H plus undergo reduction. But they're asking about M, right? So M undergoes oxidation. because the oxidation number increases from 0 to positive 2. Why is it 0? Because normally atom alone is 0, no charge. Here, the M is 2 plus. Can be 1 plus, can be 2 plus, doesn't matter. The oxidation number increases. Okay? Okay, question 20. This is from eh, from chapter 1 also. Okay. So, a mixture of methane and chlorine react when it is exposed to sunlight. The following equation represent the reaction. Which substance is reduced? Reduced means undergo reduction. Which one undergo reduction? Just metal, right? So in this case, you can just imagine always decrease in oxidation number. You check lah. It's the best one. You can check. Okay, which element has the decrease in oxidation number? So imagine now you calculate. Okay, the best you see very simple one. You might not know CH4 then how much, right? The best you can check is chlorine. What is the oxidation number of chlorine? Chlorine molecule, no charge. 0. Imagine this. This is H plus N. Cr minus. Cr minus means negative 1. So 0 to negative 1. This is decrease in oxidation number. So it means chlorine is the one that undergo reduction. Right? Others don't even need to see lah. Okay. Okay, question 1, question 21. This one is from chapter 2. Which of the following are the isomers of for C4H9OH? C4H9OH is butanol. So there are 3 different ways to draw butanol. So the first one, what you can do is, okay, this one isomer. So you see the normal one is like this. You got three isomers. Number 1, the OH is at the first carbon. This is called butan-1O. Which we have here, right? Butan-1O. You got, not 3, sorry. You got 4 isomers. Okay, this is the first one. Second one, wait second one is quite similar to the first one. It's quite similar. It's just that you change the OH to second carbon. This is butan-2O. Be sure they don't give. Okay. Then, what you can do? Do you know what you can do? Remember I told you, right? In the lesson, I told you, yes, the branch. You can stack 1 carbon on top. Remember this? In the middle, right? So, in this case, why so laggy already? Oh no. Another 2 is like this, How you got 3 carbon, 1 carbon on top. But total still got 4 carbon, but you stack 1 carbon on top in the middle. Okay, which become the 2-methyl, correct? Because the branch is at the second carbon. Right? Then I draw for you. My light pad is so laggy. Okay. So, and then this is the straight chain. The straight chain is propene. I mean, not propene. This is propanol, sorry. Okay. So, and then this is the 2-methyl one. The branch is 2-methyl, right? So yes, you can see that here got 2-methyl, right? So, but you see, you got two choices. You can stack it. You can stack the OH at first carbon. I mean, okay, you got hydrogen. Later, of course, if they ask you in structural questionnaire or essay questionnaire, you have to draw your own hydrogen. You have to draw your own hydrogen. But here now to save time. Okay. So of course, here all have hydrogen, hydrogen, hydrogen. This one you know, right? Then this one is called 2-methyl. Part one, this is already 2-methyl. This is already propanol, but the OH is at first carbon. This is called propan 1O. Then we got another choice, quite similar, but another choice like this. Another choice is the OH is at second carbon. Quite similar to the first, quite similar to the third one. You just change propan 1O to propan 2O. The drawing branch, just write CH3. Yeah, correct. I can just write. No lah, better don't lah. In SPM, better no lah. Can better no lah. SPM better the shortcut lah. In further study, you can shortcut lah. But SPM better not. Better not. But yes, you can shortcut. Yes, can be written in shortcut. But in this case, so the best answer is third. 2-methyl propan. You got 4 isomers, right? Butan 1. Stegi, oh my god. Butan 1O, butan 2O, 2-methyl propan 1O, 2-methyl propan 2O. So the answer is C. Answer is C. Okay, with the isomer. 22. This is form 5, chapter 2. The following equation represents the hydration of ethene to produce ethanol in industry. Hydration of ethene. Okay, to produce ethanol. And this one you know, right? Then the C2H4, the ethene. Ethene react with water. This is called hydration. You add water. Then you will get C2H5OH. This is ethanol. They ask for the conditions. Okay. What temperature, what pressure, what catalyst. So for hydration process, remember these 3 things are temperature 300 degrees Celsius, 60 atmospheric pressure, phosphoric acid, H3PO4. Phosphoric acid. So the answer is C. Okay. And this one, this one is the hydrogenation. A is hydrogenation. Ethene become ethane. C2H4 becomes C2H6 when add hydrogen. The condition is A. Okay, 23. Compound Q has the following properties. This is form 5, chapter 2. Wait. So they told you, right? Q cannot conduct electricity. Q insoluble in water. If you see insoluble in water, right? Got 3. Now we learn, okay, I mean got 6 actually. I mean got 4 actually. So insoluble in water, normally either is alkene or alkane, alkene or alkyne. But normally you don't touch alkyne more, or ester. Yeah, the soluble in water one got ethanol and carboxylic acid. So the third point, also very important, decolorized acidified potassium manganate 7. So it It means compound Q able to change the color of KMnO4, which is what color? Purple. Okay. The colorless means change to colors. It means compound Q can react with KMnO4. Do you know what reaction is this? What is Q? Don't know. Hey. Confirm not alcohol. No. Okay, alcohol have a chance. If they write here soluble in water, that is alcohol already lah. Okay. Because it's not soluble in water, that's why it cannot be ethanol. It's because if they write here, if it's like this, then the answer should be B. Okay. Since this is insoluble, the other one that can react with KMnO4 is ethene, alkene. Yeah. This one undergoes alkenes undergo oxidation. Example, C2H4, okay, means it can react with water, react with the oxygen, okay, react with the KMnO4. In SPM, the equation is like this one. This is equation, mana sudah pergi? Lagi, oh no. Wait. Today is so laggy, oh no. Okay, so it's like this. This is equation, you will get the E10 E1012-diol. You will get the E1012-diol. C lah. Actually, B can also react.
Teacher, why is it not ethane?
Huh?
Why is it not ethane?
Ethane is not reactive. Double bond only reactive.
Oh.
Single bond normally not reactive. Normally, unsaturated is more reactive. Saturated is not reactive. Saturated is not reactive. I'm talking about single bond. Single bond is not reactive. Alcohol can also react with this to get the ethanoic acid. I told you in class about why the wine become taste become sour. Okay, this one alcohol can also be oxidized. Okay, but because only this one, that's why insoluble. That's why cannot be alcohol. Okay. (24). If you need break, you tell me. 24. Following molecular formula represents a carbon compound formed from the reaction between compounds X and Y. Or this one is, what is this? What is the formula given? What is the homologus series? If you see COO in the middle, ester, yes. This is also from 5/2. Okay. This question, this paper one came out a lot from 5/2. Okay. So, chapter 2 is popular. Okay. So now, what is this? Okay, so they give you the shortcut, right? So in this case, you see properly. I ask you one simple question. Can you tell me what is this? You know, right? How do you get ester? Ester, you get ester when carboxylic acids, the COOH functional group, react with alcohol, right? Then you will get ester. Remember this. Alcohol have the group OH. You get ester and water. Am I right? So in this case, this part is what? How many carbon? Okay, this part is carboxylic acid, which had the formula actually C2H5COOH. It means total have 3 carbon, right? This is actually just to tell you the name, C2H5COOH. This is called, wait, what's it called again? This is propanoic acid. 3 carbon, 3 is propanoic acid. Okay, so you find which one has 3 carbon. For X, right? Because X is COOH, right? So it can be A or B, right? Correct. C is butanoic, donkey is pentanoic. Cannot, okay? Cannot. So then the other part is what? The other part should be the alcohol one, correct? Which is C3H7OH, correct? You know one, you know one. Do you know how to take out water, right? In this esterification process, normally you take out water, you take out H from alcohol, OH from acid. That's why I highlight this. This is the product, which is ester. Ester, the water has already been taken up. So you got 3 carbon again. This alcohol also got 3 carbon. Which alcohol has 3 carbon? B and non Q. So the answer is B. You understand? It means the front part is carboxylic acid. The back part normally is alcohol. Alcohol part.
Teacher, I don't understand.
Huh?
I don't understand. I don't understand.
Don't understand. Which part? Like
Uh,
what? What you don't understand?
I don't understand like the
You don't understand what you don't understand.
I don't understand the 24 like this question.
This question Yeah lah,
Yeah.
this question is ester You learn esterification, is it?
Yeah.
Acid react with alcohol.
Yeah. It's
This is the formula for ester.
oh okay.
The half part shows you the formula for acid, carboxylic acid, which is had 3 carbon, correct?
Carboxylic acid.
Yes, this carboxylic acid had 3 carbon. It shows you in ester. Okay. The other part should be the other part is the part for alcohol. This alcohol also got 3 carbon. Am I right?
Yeah.
Yeah. So that's why you just find the one that have 3 carbon. That's all. Because the actual equation. The actual equation uh is like this: C2H5 COOH react with C3H7OH. Acid react with alcohol. You will get the ester C2H5 COO C3H7 and water. This is esterification. You see, they'll take out OH from acid. They'll take out H from alcohol. So you will get H2O at the other side. Then the leftover you combine as ester. You see, right? Eh? C2H5O. C2H5, COO, C3H7. Answer. Yes or no?
Teacher, I answer everything except for the last chemical equation. Like the C2H5COOH plus C3H7OH equals to C2H5COO C3H7 plus H2O. Because you take out the OH and H from
From alcohol and from acid.
alcohol and the acid, you get water. But then the other
Then the
one,
other, the leftover combined become ester.
oh, the leftover is ester. Okay.
Leftover is ester. Yes. That's why you get formula. This one.
Okay. Then what is the like the compound X and Y here?
X is, you see that X is COOH ma. COOH is acid.
Oh, so
YOH ma. OH is alcohol.
okay. But
Yeah.
so why for B, right? Why is there CH3 CH2 CH2 two times?
They give you in a long form. The other way to write the formula.
Okay.
This, it means this is equals to this.
Okay.
But I know it's confusing because they split like this. It's kind
Yeah.
of like drawing. Yeah, they purposely do like this so that you won't see so clearly, right?
Yeah, yeah.
This how they turn up, right? But you can see through like amount of carbon. You can see through the amount of carbon. Cannot be.
Also must be one by one here, except for the OH lah. Like the carbon must see like how many carbons there. Like for compound X for B, there's like 3 carbon.
Yeah, 3 carbon each. Ne? Here got 3 carbon total, correct?
Yeah, correct.
Alcohol also got 3 carbon.
Correct.
Yeah, like so. Okay.
Can say
Okay. What question idea? Lagi. 25. This is Form 5, Chapter 3. Finally, Form 5, Chapter 3. Okay, so this is the thermal decomposition of calcium carbonate. Okay, normally thermal decomposition normally this thing undergo an endothermic because this thing you have to heat you have to heat you heat this thing, then this calcium carbonate will absorb heat, then it will decompose itself, become calcium oxide residue and also carbon dioxide gas. So they told you this heat absorb, right? Heat absorbed when 1 mole of calcium carbonate decomposed is 540 kilojoule per mole. So what is the correct energy level diagram? Very easy one, okay? Just remember this endothermic absorb heat, right? So they give. Okay. Surrounding of temperature decreases, become cold. Heat is absorbed. And remember, the energy level diagram is like this. Because the reactant has lesser heat energy compared to product. Lesser total energy compared to product. Absorb means you increase the heat. Reactant has no heat, but absorb heat when the reactant, when the calcium carbonate, when the reactant absorb heat, now product have more heat energy. And one more thing, don't forget, the action of heat absorbing for delta H, always remember this is delta H, right, is positive sign. So you find uh, A and B graph is correct. The sign must be positive. So the answer is B. Always reactant less than product for endothermic, for heat absorbing. Okay? Answer, no answer?
understand here.
Yeah, this part is too hard, right?
Yeah.
Okay. 26. Form 5, Chapter 3 also. This is the heat of neutralization. Okay, they ask you which chemical equation produces highest heat. Okay, so normally, I told you, right? Normally, when the heat of neutralization very high, normally it's between the strong acid and the strong alkali. Strong acid and a strong alkali normally produce a very high heat. If you see weak means lower already. Okay, so in this case, like if you see the ammonium oxide, ammonium hydroxide. Okay, but since a lot of these are also strong and strong alkali, right? So you need another one to qualify lah, to differentiate. So another one should be who is okay, see strong acid you got HCl, H2SO4, HNO3. But actually, sulfuric acid H2S4 can produce 2H plus, which is called diprotic acid, right? So that's why if the more H plus you can produce, okay, which you resulting that produces also higher total heat energy released. Okay, so normally it's C or donkey lah. But normally ammonium is weaker one. This side B this side this ammonium hydroxide come which is ammonia, right? Ammonia is weak alkaline. Ammonia is weak alkaline. Okay, so it cannot be donkey. Okay, it cannot be B, cannot be donkey. So it cannot be A and C, right? But C is stronger because C using sulfuric acid. 2 times stronger. Let's say if A releases 50 kilojoule per heat, releases 50 kilojoule, right? Then C can release total 114 kilojoule. 2 times. Okay. Okay. Question 7 and 27. This is Form 5, Chapter 4. Diagram 14 shows the structural formula of a monomer. This is recently we learned. This is polyvinyl chloride used to make water pipes and all this. The structure of polyvinyl chloride. I mean, this is vinyl chloride. This is the monomer, right? Or you can call it chloroethene. Okay. Which of the following is a similarity between the monomer and polymer? Now, in this case, the thing is like this. So what happens is n amount of CH3Cl, n amount added together, you will get a lot of CH3Cl, the polymer. Right? Now, the thing is, see, and the thing is, the structure, right, from double bond. I draw for you, this is how you draw the monomer, right? When it become polymer, they become single bond. Okay, I know you're correct again. Okay, very good. Okay, fine. So you become single bond. That is monomer has single bond. Has double bond. Sorry, monomer has double bond. Polymer has single bond. So B cannot be correct already lah. Wrong already lah. Right? Cannot be both because polymer is single bond. Molecular formula is C2H3Cl. No. Okay, cannot be C2H3Cl. You don't know what is the molecular formula for. Okay, you see, if it is empirical formula, both is empirical formula, both is CH3Cl. Molecular formula, only for monomer is CH3Cl. Polymer, you don't know how much. And polymer, it can be 50 carbon, 100 carbon. Don't know how many. Okay, so you cannot assume molecular formula is this. It's not CH3Cl, sorry. I even wrongly show you. C2H3Cl, sorry. Sorry. C2H3Cl. Yes, the monomer is C2H3Cl. Okay. But you cannot assume uh you cannot assume molecular also C2H3Cl. Molecular, the amount of carbon can be 100. Okay. You see n times, right? Don't know how many times. Empirical, yes. Empirical is C2H3Cl. Okay. Both got carbon, hydrogen, chlorine. Okay, correct lah. C. Okay. Both got carbon, hydrogen, chlorine. Number of carbon atoms in the molecule. I cannot, again, you cannot assume monomer is 2, polymer is also 2. Cannot. Okay, this is 27. 28 is, which substance speeds up the coagulation of latex? This one is just recently done again. This is also form 5 chapter 4. You want latex to coagulate, normally you add acids. Normally you add weak acid. So very obvious, the answer is donkey. This one I think I just taught this way. Right? This one is to prevent coagulation. C is to prevent. Okay. 29. This one is form 5 chapter 5. Which food additives is matched correctly with this example? Now I know you all haven't learned this, but I will also talk about it because I need to post this on YouTube. Okay. So yeah. So it's food additive 5.3. Antioxidant ascorbic acid. Ascorbic acid is vitamin C. Which is correct? A is correct. Okay. Aspartame is flavoring. It's a bit like, your Coca-Cola. Why is it, even though it's less sugar, not zero sugar, why you still feel the sweetness? Because they add aspartame. Okay. Preservative. Yes. Okay. Memorized chapter, yes. A lot of memorizing. C is the MSG. Now your uncle or Joe, you know this, okay? MSG. So it is also flavoring, right? To bring sweetness. Not preservative. Donkey azo compound is colorings. Okay. You got 7 food additives. Okay, you learn. I teach you next week, next month. You got 7 food additives. You got preservatives, thickeners, coloring, antioxidant, flavoring, stabilizers, emulsifiers. So you got 7. Each one has its own example. Okay. Okay. Question 30. This also from Question 30 is also from 5 chapter 5. Okay. This is 5.2. The soap and detergent. Okay. So this is preparation of detergent. Normally detergent have this part. This is the OSO3 part. OSO3 negative. Okay. So OSO3 negative. Okay. You see, OSO3 negative. To get your detergent undergoes 2 processes. Okay. The first part is called when you add long chain alcohol with sulfuric acid. This process is called sulfonation. Or if you see in this case, in this question, they give you sulfation. Same thing. Means you add sulfuric acid. Okay. Alcohol add sulfuric acid, you will get this alkyl hydrogen sulfate. Okay. So, and then you add this alkyl hydrogen sulfate with sodium hydroxide. Actually, this part got H plus. Okay, got H plus. H plus react with OH minus, react with alkyl, sodium hydroxide. This is neutralization. So to produce detergent, you got to process. First is sulfation, second is neutralization. So the answer is sulfation first one, second neutralization B. The process to produce detergent, two processes, sulfation and neutralization. To produce soap, only one process, saponification. Okay. 31. This is Form 4, Chapter 3. A calculation actually. Diagram 16 shows 4 types of fertilizers sold in a shop. Okay. Ahmad is advised to buy a suitable fertilizer for better growth of rambutan tree. Okay. So here they give you 4 samples. You got urea, ammonium nitrate, ammonium sulfate, ammonium phosphate. So in this case, they ask, okay, which of the following fertilizers becomes Ahmad's choice? When you choose fertilizers, you have to remember one thing. Okay, so you have to remember one thing. You always choose the highest percentage of nitrogen content. You always choose the highest percentage of nitrogen content. Yes. Okay. So it means when you calculate that later on, you have to get which one is the highest. Okay. So why do you ask why is that this? Okay, because nitrogen is very important. It's a key limiting nutrient. Okay, for plant growth in many soils. That's why normally many soil they always choose like you always see urea as the best example. Okay. So I'm not sure. I'm still not sure yet. That's why I calculate for you lah. Okay. So if it means your when your plants don't have enough nitrogen, your plants will become stunted cannot grow properly. Don't have enough nutrients. Okay. So it become like stunted, become yellowish leaf, right? Okay. So yeah. In this case, but of course you must. Then I put a lot of. Of course, you cannot, you only can put suitable amount. Okay, suitable amount. You cannot put too much, you cannot put excess. Okay. Later on the plant it become like this, become weak stem. Okay, become weak stem and also like cause environmental pollution also, which is also possible in this case. So we calculate one by one. Okay, they give you the formula already. Urea. First one, urea. One by one calculate for you. CONH22. Do you know how? Total put on bottom. Number of hydrogen put on top. You see, bracket 2. So on top also got 2n. Then you multiply 100%. It means you have to put the monomer side. So 2 naturally is 2 times 14. Bottom is 12 plus 16 plus 2 bracket 14 plus 2 times 1 times 100%. It means this question takes a lot of time, right? You have to compare 4 fertilizer. So you will get, okay, let me see. Urea, you will get 47%. Around there. Or I think you will get 46.67. So you round off to 47. Then we calculate also for ammonium nitrate. But even you don't have to calculate. If you see this questionnaire, you just think ammonia, urea. But if they come out in, if you just normally choose urea, but if you come out in uh structural question, then you have to show the calculation, right? So ammonium nitrate, percentage of N, sorry, N, percentage of N, alamak, wait, so laggy. It means again, and you got two N at the top. I mean, in the formula, total NH4NO3 times 100%. So 2 times 14. Bottom is 2, 14 plus 4 times 1 plus 14 plus 3 times 16. I'm sure at this point you know how to calculate the monomers already. Just follow the amount, follow the monomers given. I mean the RAM given. Ammonium nitrate, you will get 35%. Am I right? Another one is ammonium phos. Eh? Ammonium sulfate. Again, 2N at the top. Put the thing that you want to find on top. Put total on bottom. Multiply 100%. Kind of 2 times 14. 2 bracket 14 plus 2 times 1 plus sulfate is 32 plus 4 times 16. For ammonium ordering, ammonium sulfate, you will get 28%. 21%, sorry, 21%. And then do another one in this ammonium phosphate. Ammonium phosphate got three N. So 3 times 14. 3 bracket 14 plus 4 times 1 plus P is 31 plus 4 times 16 times 100%. You will get 28%. So you got 21%, 28%, 35%. Urea is 47%. Of course, you choose urea lah in this case. Okay, you choose urea. So the answer is A. Okay, let's look at question day 2. Okay, so he said, I want to add 50 cm³ water in distilled water into the volumetric flask. Okay, so and then they say, she said this volumetric flask contain 200 cm³, 0.5 mole per cube hydrochloric acid. Now, if you see it, in this case means now this part is to prepare standard solution, Form 4, Chapter 6. Okay, so is 6.6. Prepare standard solution. Prepare the solution that which the concentration is accurately known. Okay, but you got two methods, right? One is weight method. Weight method normally start from solid. Then you weigh the mass of the solid. But this one is not solid. This one is the stock solution. Okay. The stock solution is 200 cm cube, 0.5 mole per meter cube. Okay. So this is the second method. The second method is called dilution. You know what is dilution like? Dilution means dilute. Dilute means to add water. Dilute means dilute means to add water. Dilute is to add water to decrease the concentration. To decrease the concentration of the solution. In this case, is to decrease the concentration of hydrogen ion, right? Because this is hydrochloric acid. So, yeah. 很淡 yes, correct. 很水 watery, okay, yes, correct. So, what is the final pH value? Okay, so this requires a lot of calculation. Okay, so dilution formula is M1 V1 equals to M2 V2. Because actually you might ask, how does this formula come? When you add water, the one thing won't change, it's the number of mole. Number of mole won't change. That's why actually N1 can be equals to N2. N is a symbol for number of mole. So, which also means M1 and MV of 1000 can be equals to MV of 1000. Because, because number of mole equals to MV of 1000 before equals to after in this case. But the different thing is, in this case, the M, which is the concentration, or we call it molarity, and the V, which is the volume of solution. Yeah, so then the 1000 cancel off, then you will get M1 V1 equals M2 V2. This is like the derivation. Okay, so what is M1? Now, at the beginning, this girl say the volume is 200. So the 200 is V1. The concentration at the beginning is 0.5, which is M1. Then you add 50 cm water. So which you has the V2 information. So the thing that you're missing is M2, right? So it means you have to find M2. So M2 in mathematics, you can get from when you use M1 V1 divided by V2. So M1 V1 is 0.5 multiply 200. What is V2? What is V2? V2 is not 150. Wrong. V2 is 250. Because at the beginning is 200 cm cube. V1. V2 is V1 plus water. You plus 50 cm cube water. Your V2 supposed to be 250. Be careful this. Okay. So you will get how many? 0.4 mole per dm cube. They ask what is the final pH value. What is the formula for this? Okay, this is hydrochloric acid. So, acid contain hydrogen ion. What is the formula for pH? Remember, pH, you got three formula, right? For acid is pH equals to negative log H plus. So, how do you get H plus, remember? Okay, let's say I want to make H plus. No need to make H plus, sorry. I can straight away substitute. Sorry, I can straight away substitute 0.4 because in case you check, hydrochloric acid is a monoprotic acid, only produce one mole of hydrogen ion. That's why you know you times 2 for the concentration. If they give you sulfuric acid, then you have to be careful. Then your concentration have to multiply 2. Because sulfuric acid is diacritic. Okay, but this one should we put negative log 0.4? You will get 0.40. So the answer is C. Yeah. So this requires 2 formulas. Okay. Vậy tôi cái. Any question? Okay. Question 33. This is form 4, chapter 7, calculation. Diagram 18 shows a graph for the reaction between zinc and copper 2 sulfate. So very obvious, this guy trying to measure the change in the reactant, okay, per unit time. So that's why you see the graph decreasing, right? So this is the result, right? But in this case, they measure the mass of zinc, which is keep decreasing, of course. But, okay, sorry, I'm blocking the graph. So because you have to use this graph to calculate. So you see at the beginning, the mass of zinc is 5 gram. After reaction, left 1.5. 1.5 is at this. When it is 50 seconds, it reaches 1.5 gram. Left only 1.5 gram. So in this case, do we take 60? No. Okay. The reaction ended. 那个 reaction 完了, it ended at 50 seconds, not 60 seconds. So you don't care about the 50 seconds. I mean, you don't care about the 60 seconds, sorry. Okay. So what is the change of mass? How many mass of zinc reacted? You have to use 5 gram minus 1.5 gram, right? So what is the rate of reaction? The reaction is 5.0 minus 1.5, huh? Okay, this is the change for the mass of reactant. The zinc that has reacted, how many? Okay, over the time, 50 seconds. So you get 0.070 gram per second. This is gram, this is second. Right, gram and second. So the answer is donkey. Diagram 19 shows the electrolytic tank used to extract aluminum from its ore, aluminum oxide. Okay, this is the form 4, chapter 3 calculation. Okay, the number of mole calculation. So they give you the equation, aluminum oxide. Okay, after undergo this extraction to get aluminum and oxygen gas. Okay, so this one, actually this concept is from form 5, chapter 1. Alright, extraction of metal. So, but the calculation is form 4, chapter 3 lah. So, what is the mass of aluminum extracted? Okay, so very easy lah. So they give you aluminum oxide is 1000 kg. 1000 kg. You see, the final answer also in kg. So I think you leave it as kg lah. Okay, in this case. Or if you want to change to gram also can lah. Since normally you use gram, right? So 1000 kg equals to how many gram? 1 kg equals to 1000 gram. So 1000 kg equals to 1 million gram. So the exam sometimes they like to give you big number. Okay. So in this case, 1 million gram of aluminium oxide. You write down the information. 1 million gram. 1 million gram. 1 million gram got 6 zero. Be careful. 6 zeros. So they ask what is the mass of aluminium extracted. So they want to find this mass equals to question mark for aluminium. Three steps. First step, find the mass and find the number of mole. Second, ratio. Third, mass. Yes. Okay. So first step, in case for those who still don't know, number of mole equals to mass over molar mass. Number of mole equals to mass over molar mass. So if you want to find the number of mole, if you want to find number of mole of aluminum oxide, you use what is mass? Mass is 1 million over molar mass is 2 aluminum. Okay, don't include this 2. This 2 is of ratio later. The big number don't include. They include only this. Include only Al2O3, not the big 2. Only this Al2O3. So 2Al is 2 times 27. 3O is 3 times 16. This one you will get 102, right? So 1 million divide 102. You will get quite a big number, okay? You will get 9803.9216 mole. Okay. So then you do ratio lah. Okay. So ratio means 2 to 4 from equation. From equation 2 to 4. Ratio how? Ratio from. So it means you got if you got 2 more aluminum oxide, you will get 4 more of aluminum from equation. Then if you got 9803.02 from 9216 mole of aluminum oxide, then what do you get? Times 2 means you will get times 2 times 2 you will get 19607.8432 mole of aluminum. I know it's a bit crazy, but yeah. The crazy is at the big number. Not anything but the big number. Sorry, yeah, can. And then you use this mole to find the mass of. How do you find the mass? Number of mole multiplied the molar mass. Molar mass of aluminum is 27. So you use this number. It means if you want to get mass of aluminum, you use 19607.8432 multiplied 27. So you will get 529411 gram. Round off to. The answer is in kg, is it? So you can round off to 529 kg. So the answer is B. Okay. This one, okay. It's the same format. It's just that the number is a little bit big. Okay. Quite big. In industry, right? This process is in industry. So of course, not a small lab. Okay. It's in big industry. Okay, 35. The following equation represent the reduction of iron trioxide by magnesium. This is another one for number of more question. From another form 4 chapter 3 question. Okay. So what is the mass of magnesium needed to reduce 16.0 gram? Keyword 16.0 gram iron trioxide. Iron trioxide is Fe2O3, 16.0 gram. Then they ask what? Mass of magnesium. It means for magnesium, mass equals to question mark. Again, the same thing, right? Number of mole ratio mass. Okay. So yeah. So the first step, number of mole of iron 3 oxide. Again, same thing, right? Mass, right? So use formula, number of mole equals to mass over molar mass. So you use mass is 16 gram. Remember, you always start with the one that has information first, which is Fe2O3, right? 16.0 gram over 2Fe. 2Fe is 2 times 56. 3O is 3 times 16. I believe you will get 0.1 mole. Then ratio again, ratio is 1 mole. Don't have number means one, one from equation, 1 mole of Fe2O3 react with 3 mole of Mg. 1 mole of Fe2O3 react with 3 mole of Mg. It means if you got 0.1 mole of Fe2O3, then you have to multiply 3. Multiply 3 means you will get 0.3 mole Mg. Then again, if you want to find mass, use number of mole to multiply molar mass. Right? So the third step is mass of magnesium is 0.3 mole multiply 1 mg is 24. You will get 7.2 gram of magnesium C. This one is just, again, the 3 steps. First, number of mole, to find number of mole. Second, to find the ratio, mole ratio. Third, to find the mass. Okay? (36). Okay, also form 4 chapter 3 calculation. Okay, what is the molecular formula? The empirical formula. The empirical formula is CH2. Remember, right? The simplest ratio number of atoms is CH2. Ratio 1 to 2. Carbon to hydrogen. What is the molecular formula? The real formula for this hydrocarbon. So it means there's one formula. Molecular formula is equals to bracket n. Yes, equals to bracket n, correct? Okay. So n times of empirical formula. N times. Right? So is it this way? Okay. So it means, okay, the empirical formula is CH2, right? What is the total mass? 56 gram per mole. So very easy lah. Okay, just to find n how much, how many times. So you put the molar mass inside. 1 carbon 12, 2 hydrogen means 2 times 1. Total 56. Then you will get 14n equals 56. N is 56 divided by 14. You will get 4. It means your CH2 have to multiply 4 times. You will get C4H8. 8. Which is butene. (37). 37 is Form 5 Chapter 3 calculation. Okay. The following information shows the result of an experiment to determine the heat of combustion of fuel X So this one is, I don't know what fuel is this, but they tell you mass of fuel X burnt is 18.0 gram. Volume of water is 250 cm cubed. Increase in temperature data is 16 degrees Celsius. Okay, so what is the heat of combustion for fuel X? 3 steps to find delta H. Okay, so because delta H equals to Q divided by mole, but first step to get Q is Q equals MC theta. Second part is number of mole equals to, in this case, for combustion is mass divided molar mass. For other type of heat is heat of reaction is MV over 1000. But in this case, it's mass over molar mass. So Q equals MC theta. M is Q equals to MC theta. The M is mass of water, not mass of fuel X burnt. No. Okay. For M is 250. Be careful this. For mass, for M theta, M is mass of water. C is the fixed, always the fixed, right? The specific heat capacity in chemistry, 4.2. Fixed given. Theta is 16.0. I believe you will get 16800 joule. Then number of mole. Number of mole fuel X. Okay. Mass over molar mass. Mass of fuel X burnt is 18.0 gram. Molar mass is, they already told you here. In this question, they told you molar mass is 180. 0.1 mole. It means the final delta H. What do you do? 16800 joule divided by 0.1 mole. And you will get, and remember, heat of combustion is exothermic. Delta H is negative. So you will get negative 168,000 joule per mole. But you have to shorten to kilo, see? So shorten to kilo means divide by 1000. You get negative 168 kilojoule per mole. The answer is C, 168.00 kilojoule per mole. Okay. Any question, any problem with the calculation? You remember this paper is 1 hour 50 minutes. Okay. So you see how long we discussed. Okay. So it means in the same time means you have to use your time wisely, right? Yeah. Have you used time wisely. Fun part, normally you use less time. This calculation takes more time, right? I go now. Haha. Okay. So in this case, the following equation represents the decomposition reaction of zinc nitrate. Okay. So this is another number of mole calculation from 4 chapter 3 also. Calculation. So what is the maximum volume of nitrogen dioxide gas released at standard temperature and pressure? So what is the volume of nitrogen nitrogen dioxide. Nitrogen dioxide is NO2. Okay, so it means you want to find this V equals to question mark. Volume of NO2 how much? When 18.9 gram of zinc nitrate was heated. Okay, zinc nitrate is this one, first one. So again, 3 steps. Find number of mole using this mass over molar mass. Right? Do mole ratio, zinc nitrate to nitrogen dioxide. Third, find the volume using, see, they give you some more molar volume, right? So it means you have to use volume over molar volume. First step, same thing. So what do you do? First step, again, number of mole of zinc nitrate is mass, mass is 18.9 gram. Molar mass, they already told you. The whole mass is 189 for zinc nitrate, which we get 0.1 mole. Second step, do ratio. Here you got 2 to 4. So 2 mole of zinc nitrates to 4 mole of nitrogen dioxide. So it means you have to multiply 2, right? If I got 0.1 mole of zinc nitrates, multiply 2 becomes 0.2 mole nitrogen dioxide. Third, find the volume. Volume of nitrogen dioxide equals to volume. If you want to find volume, use number of mole multiply molar volume. Number of mole is 0.2 just now. Molar volume is 22.4. So you will get 4.48 dm cube. So the answer is donkey. Again, the 3 steps. Okay. Any question?
No, sir.
Yeah. Question 39. Now, if you see strand of graph, right, you normally think of catalyst already. This is Form 4, Chapter 7. Okay, you normally think of catalyst. So diagram 20 shows energy profile diagram that contain from 2 cell experiment. Normally you think they got 2 cell experiment. You see this graph, right? One got catalyst, one no catalyst. Which one have presence of catalyst? Normally, if you got no catalyst, the activation energy will be higher. It's like because catalyst, if you got catalyst, it can increase the rate of reaction. It means the reaction uses shorter time to complete. Okay, so it means you can think as if you got catalyst, you can walk shorter path to home. No need to waste so much energy. So normally set 2, it means set 2 normally you have catalyst. Set 1 no catalyst. Imagine that set 1 you have to use your leg from walk from school to home. Set 2, there's a transporter. Your catalyst is a transporter. The transporter bring you back. You no need to save. You no need to waste so much energy. Okay, so it means set 1, there is no catalyst. Okay, so and then there's one more thing. Okay, this one also a little bit mixed with Form 5 Chapter 3 because They also ask for absorption of heat, releasing of heat. So you see, at the beginning, isn't it have higher energy? The reactant have higher energy. The product have lower energy. It means the graph looks something like this one. Total energy content of reactant is higher than total energy content of product. So this is exothermic reaction because the heat is being released. Okay, so it means it must be heat release. Okay, it must be release. If you see release, releases heat energy, that's correct. It means C and D is wrong. C and no is wrong. Okay, so only get A and B. So A and B releases heat energy, but set one without catalyst. Set one without catalyst, set two with catalyst. Yes, so answer is A. B wrong. Okay, B wrong. If you see the activation energy lower, means have catalyst. If you see the activation energy higher, no catalyst. Okay? This is called the activation energy. You have catalyst, then you can achieve, the particle can achieve lower activation energy. Okay? Any question?
Teacher, what's the activation energy from the graph again? Like, what's activation energy?
Again, what is the?
Activation energy.
Means for the reaction to occur, the particle itself must have energy for them to collect, for the zinc and the H plus to collect. For the zinc atom
So,
and the H plus to collect, this is called activation. To activate them, to make sure they have reaction, and then they must have activation energy. And normally,
but teacher, yes, sir.
it
Sorry.
means it means the particle, right, uh, need to have at least equal or more than the itself energy. We call it activation energy. Then only the reaction can occur. Then only the particle can collect each other. If no, then the reaction won't occur.
But teacher,
Yeah.
why catalyst got lower activation energy? Does catalyst speed up reaction?
Catalyst speed up reaction, yes. Also can
Also,
increase the rate of collision. The frequency of collision increases. Frequency of effective collision increases. It means they collect more frequently, more often. So they can use shorter time to finish the reaction. Or you can say higher rate of reaction. Yeah, higher reaction means normally you uses lesser energy. It's like I told you right just now. Got catalyst, save energy. No need to work so much. Work shorter. Okay?
teacher.
Okay. Last question 40. The diagram 21 shows the process of to confirm the presence of cation salt in solution. This one is we had also. So it's form 4 chapter 6. Okay. So cation test got many. Okay, but this one is the white precipitate one. Okay. Then I'll go back to this. Okay. So this one is a ZCM confirmation. Okay. So I teach you a shortcut. So in this case, this one look confusing, I know. You see, one they add NaOH, sodium hydroxide. The other one they add ammonia. You see. Then you got a lot of result form. Okay, then you add some more excess. Okay, you might be very confusing, but I teach you a shortcut, remember? The shortcut is ZCM. Okay, you can remember as such is small, so such is small. So you might ask, what does ZCM stand for? Z stand for zinc ion, A stand for aluminum ion, P stand for lead 2 ion, C stand for calcium ion, M stand for magnesium ion. Okay, then you split the Z and Cm. And don't forget, the first thing that you add is NaOH. Of course, you also add excess. Second, you add ammonia. You also add excess. Third one, you get Ki, potassium iodide. Okay, so then you remember, okay, four W's, four W's, four W's. It means WW. Then you split the Z and AP again. You split again for the ammonia part. Then WW. They got four W's. WWWW. Like a website, you can remember. And then you split the C and M. Then you got NW. NW Norway, right? You can remember as WWWW Norway. And then A and P remember as New York. NY, New York. Then after that, you add the P. P is the precipitate, which also means WP is what? Precipitate. And P means no precipitate. It means the thing dissolve. YP means yellow precipitate. Then another part, what I do is you do tick, cross, tick, cross, tick, cross, tick, cross. Tick means dissolve. X means do not dissolve. Okay. So I explain to you lah. What does it mean? Means, in this case, they want to detect what is the ion form in a test tube. Okay. So let's say lah, let's say what is, let's say in a test tube, like in the water, right? You don't know which ion form. That's a problem. So that's why it means you have to put some chemical to test to prove what is the ion inside. All right. So example, let's say it's a test tube, but I don't know which ion form inside. It can be zinc, it can be aluminum, it can be calcium, it can be Mg, it can be Pb. So this first one I have to add NaOH. You see the result? If I add NaOH, I got white precipitate is formed. So, but if you add NaOH, white precipitate form, it can be Zn, Al, Pb, Ca, Mg. Am I right? Okay, but later on they add excess again. See, they add excess sodium hydroxide, excess, then white precipitate dissolve. White precipitate dissolve. Which one, when you add excess NaOH, white precipitate dissolve? Which one? It can be zinc. Possible is it can be zinc, aluminum, or lead. So you got three, the ZAP. It means it can be Zn, Pb, Zn, Al, Pb. Am I right? Yeah. So not just this side, right? So, and then since either of these three, right? Then you can add ammonia again. See this guy add ammonia. Again, white precipitate is formed. So, but if you add ammonia, both got white precipitate form. Right? Both got white precipitate form. So you still haven't decided. And then you add excess ammonia again. White precipitate not dissolve. It means this is WPX. The first one is WP thick. And when you add NaOH, the second one is when you add ammonia, excess ammonia, WP cannot dissolve. When you add ammonia, WP cannot dissolve. It means in this case, we only got it means it cannot be zinc anymore. Okay, zinc is out. It means it can only be aluminium or lead 2 ion. Okay, or in this case, of course, it can also be magnesium ion because they didn't have the order. Of course, it can be magnesium ion, also possible. But since since here right, the first test don't have magnesium ion, right? It means we prove that magnesium ion is not present. In the second test, we prove that zinc ion is here. It can be magnesium also, right? But in the second test, we prove that zinc ion is not present, so it also cannot be zinc, right? So it only can be aluminum ion or lead 2 ion, Al3 plus or Pb2 plus. But since here don't have Pb2 plus, right? The option don't have Pb2 plus, so the best option is A. It means you can add, actually, the third test, if you can add Ki, potassium iodide, to test. If you got yellow precipitate, then it's Pb2 plus. If you got no precipitate, straight away dissolve, that is aluminum. After you add 3 tests. Yes, so the answer is A. This part is a bit troublesome if you don't understand this part, the cat test. Okay, any question to ask for question 40?
Teacher, I don't understand like the white precipitate, no white precipitate. The last part, the table part.
You mean when you add ammonia? You mean you add ammonia or NaOH?
About the last part, the ZapCM, but I understand the symbol of the ZapCM, but I don't understand like add ammonia, excess ammonia, and
This is just a test to detect which ion is present inside the test tube. So it means we prove that inside is aluminum ion.
also like for that means like if we add ammonia into sodium.
If the white precipitate cannot dissolve, it means the possibilities between aluminum and lead 2 ion based on the polymerization, based on the result. Because we use our eyesight cannot see the ion, so you have to add chemical like this to test which ion present. Understand? It means in a summary, it means I tell one more time. If you add excess ammonia, if you add excess sodium hydroxide, you see, you got white precipitate dissolved. White precipitate dissolved. When you add NaOH excess, you get WP dissolved. It can be either zinc or aluminum or lead 2 ion, correct? Either of the three, right? Either one, right? You don't know yet, right? But when you add ammonia, excess ammonia, you get WP, white precipitate, do not dissolve. do not dissolve, then WPX. When you add excess ammonia, WPX is aluminium, lead, or magnesium. Am I right? But since the first test don't have magnesium, of course it cannot be magnesium. You see, it must be like both having the both present like that. Then only you can say the ion present. Correct? Or same thing, the second test, we cannot prove zinc ion present. I mean, not say cannot prove, but we shows that zinc ion does not present. Because in second test, we didn't get WP dissolve. In second test, we get WP do not dissolve. So zinc is out. Zinc is out, magnesium is out. So only either is aluminum ion or lead 2 ion. Since here don't have lead, right? The option didn't give PV, right? So the best answer is aluminum. Answer.
It's the
Okay. So